Okay, I don't know if you remember that, if I've ever shown you one of these smart video clips, but I do have to keep them within 5 or 6 minutes. It takes a long time to render. Anyway, I wanted us to pick up where we left off yesterday. We had set the stage for resolving vectors, and we had two vectors, u and v. We don't want them to be zero vectors, because the zero vectors, they're just not fun to deal with or anything. They're just kind of a special group among themselves. So we kind of exclude them from being possibilities for u or v. Also, what we set the stage for yesterday was to let u have the component vectors u sub 1 and u sub 2. So if you added the u sub 1 and the u sub 2 together, you would get vector u. And u sub 1 and u sub 2 we defined day before yesterday, which was Monday, and we'll have the same definitions as we had there. W sub 1 vector is parallel to v. In other words, it's the vector you get when we project u onto v, and it's going to be run along parallel to v. It could be the same length, but probably not. It could be shorter, it could be longer. W sub 2 is that orthogonal vector to v that we stated was the difference between, or the sum of vector u plus the opposite of w sub 1 vector, which simplified into u minus w sub 1 vector. And we've talked about the situations, the two different situations that are important to us multiple times now. The two exciting cases for the measure of the angle theta is acute or obtuse. So we have this one picture where theta is acute. We project u onto v, and it's longer in this case. And it is just the way I drew them this time, that u was much longer than v. And u, vector u, is the sum, if you notice, of w sub 1 plus w sub 2. Right? The other case or situation that you could have, as we stated on Monday and reviewed again yesterday, is that theta, the angle between the two vectors, vector u and v, could be obtuse. So when you shine that light down and you project u onto v, it's going to go the opposite direction. It's going to be over here. This is w sub 1, and that's the projection of vector u onto v. And this would be the orthogonal component, w sub 2. But again, vector u is the sum of w sub 2 plus w sub 1 plus w sub 2. All right, so we've talked about those two situations quite extensively. And what I want us to do is to look at this example here, find the vector component of u, and we're into the plane again. All right, we're going to scale it back down to the plane. And it has components 5 and 10. And you want to find the vector component of u that's orthogonal to the vector v with the components 4 and 3, given that the projection of u onto v, which is w sub 1, takes you to 8, 6. And u, which has the components 5 and 10, is the sum of w sub 1 and w sub 2. So it's basically the situation we just drew two different cases of. And I want you to take this information and I want you to draw a diagram and try to solve this. It's going to be kind of a very systematic process I'm going to go through, very detailed diagram that I'm going to go through. And I'm going to introduce something that's going to be very important as we move on through this. And it's probably the first time you've ever seen this, unless maybe you've seen it in a physics course. All right, so this right now, this video is 4 minutes and some seconds long. I'm going to go ahead and cut it off and give you time. Ms. Bowman is there, and she's going to give you time to work this problem. She's going to have these papers so she can put that up there, or you can real quickly jot it down and work it. Then I'm going to make the recording of the solution. Hopefully I'm going to be back by then. As I said, I went to a funeral. So I'm going to cut this off, and you're just going to sit and work the problem. So either jot this information down or have Ms. Bowman put this on the document camera so you can see it.